Okay, so we got this result for the surface entropy. Okay, and we make this formula better contact with black hole entropy. So you can see that this is just A/4. So when our earlier discussion of black holes, we say entropy is A divided by 4 because we set up the natural unit taking h bar equals to 1 and g Newton equals to 1. But to plug back, to put unit back, it should be A divided by 4 times g Newton times h bar. Okay, so this is just the black hole entropy. It's analog. Let's say suppose A is the area. Suppose A is the horizon area. Then this A divided by 4 it is black hole entropy. And then you can see there's from loop on gravity entropy counting, you get a prefactor T0 divided by 2 pi, right? And well, and this T0, remember T0 inverse divided by 2 pi equals to what? Yeah, 0.274. 0.274. Okay, so it means that suppose, because Barbera image parameter is a free parameter, so suppose we set up Barbera image parameter to be 0.274, you just get black hole entropy. So equals to A divided by 4 h bar. Okay, if we set beta equals to beta 0 equals to 0.74. Okay, so this is a consequence from loop on gravity, is that for any surface you do this statistics, and the entropy is always following the area law. Okay, and but it depends on a free parameter because all the theory depend on free parameter, Barbera image parameter. So it goes to A/4, something like black hole entropy, when Barbera image parameter fixed to a specific value. Okay. And so here you see that all this calculation is done for a general surface, macroscopic surface, and of course it can apply to black hole. So this computation, I'm not going to talk about how this computation embedded in black holes in loop on gravity, because that will be a lot of other lectures. But this computation can be applied. To loop on gravity. Black holes. Okay, and for details how to carry out quantization for black holes in loop on gravity, you can see a nice review. It's pretty recent. 09. So this is by Alejandro Paris. Okay. Also, this computation also can be applied to study entanglement entropy in loop on gravity. So can be applied to tensor network. Networks and entanglement entropy in loop on gravity. The same calculation, but related in a different context. Entanglement entropy, well, entanglement entropy and holography principle, holography. So over there you can use this entropy counting to obtain something like you know, it is called some Ryu-Takayanagi formula, which is very useful in ADS-FT, but you can derive it in loop quantum gravity as well. This is some from my my own earlier work. If you're interested, you can check out. Okay. Yeah. So I think that's all I want to discuss. Right, and this is the standard computation for the black hole entropy counting, and when this total area is black hole horizon. Okay, I think this is everything of our lecture. I think that's the end of our lecture series. Okay, so is there any question? Okay, so if there's no question, so let's finish. So now we finish everything. So this is the end of the entire class and an entire series of lectures on loop quantum gravity. So I think all of you, if you follow the lecture, you should know, you should have an overview of this area, and you should be able to do all the research in loop quantum gravity. Okay. All right. So congratulations, you finished the lecture.
Okay, thank you, Dr. Han, for all those great lectures. Thank you.
Thank you.
Thank you.
Thank you.
Thanks for the effort.
Okay, so then I'll end this meeting. See you.
See you.